Coming up next, he's been on the Time 100 Most Influential People twice. You know, you're getting up to twice and you're up there with like Oprah and the Pope, so twice. Okay, this isn't a one-time deal right here. And he's the master of Elliott House, and he's the chair of the Department of Stem Cell and Regenerative Biology, speaking on stimulating cells. Professor Doug Melton.
Good evening, and thanks for having me tonight. I want to talk to you about an emerging new science, the science of human developmental biology. It's about how our bodies are made and maintained. On the first slide here, you see over on the right the human body, and we've heard different perspectives on this tonight, from a sociologist, a historian, an educator. Some of you might be religious leaders, politicians, economists. All of you have a different perspective on that entity at the right. For me, when I see the human body, I think about how is it made? How are cells differentiated? How do the different cells come together like little machines to make that entity? What I want to tell you about tonight is a fast-moving science that's going to give us dominion or mastery of how our bodies are made, and I suggest to you that it'll change your perspective on what it means to be human. Therefore, I'm going to present as an idea tonight the idea which has two threads, one from plant biology and one from animal biology, where you could have a big impact on the world. And that impact will be stimulating stem cells for better bodies and healthier lives. Now, I have to tell you two facts about biology before I give you a couple of examples. The first is, as you probably know, your body is constantly turned over. Once it's made, it's not permanent. It's constantly being replenished or renewed. So here's a little cartoon looking at my favorite organ, the pancreas. It says here, cell turnover and replenishment. And you can think about your cells being killed off and then replaced by new cells. You tend to think more of this with respect to the skin on your face or on your body or your intestines, where the turnover is much faster. You may also know that your blood turns over at a very fast rate. So even if you get bored by the rest of my talk, you should think about the following. Your body makes over 100 billion blood cells per day, which means that in the next 10 minutes during this talk, you'll make about 100 million new blood cells. It's quite amazing that our bodies can do that kind of turnover and yet maintain who we are, maintain what we remember. Now, of course, this process of turnover changes with age. So I have a picture you can think of one of the young women in the audience here tonight, and what will happen to her as her aging process proceeds. So what you see there, of course, is her skin changes, the underlying musculature changes, her brain is changing, her vision changes, her hair changes. All of that will happen to all of us. Well, what underlies this biology of replenishment and change is a cell called a stem cell. And we only need to know two things about a stem cell. They have two essential properties. The first is that they can self-renew. That is, they can make exact copies of themselves, as shown here. So one cell divides to make two, and they're identical to the mother cell. But under certain circumstances, given the right signals, these cells can also specialize to make the brain, the bone, the blood, the muscle, all of the cells of the body. I'm going to tell you two examples about stem cells, one with muscle and one with nerves, and then tie that to plant biology for the big idea. Let's take a look at muscle cells. Your muscle is made of fiber, and here in blue are nuclei from all of the cells in a muscle fiber, and your bicep would have thousands of these fibers. Another way you could think about this is the stringy part of the meat that you eat. If you look over on the right, there are some special cells. They're called muscle stem cells. So of all these cells here and all these nuclei, there's only one that has this special capacity to make more muscle. Now, how do some of you think about making more muscle? Well, most of you think about, as Dan Lieberman said, going to the gym, maybe lifting weights, running, making or maintaining your muscle. And that's all done through these muscle stem cells. But the balance of making new muscle has to be properly regulated. If you make too much, it's not good, or too little. As you know, there are ways of using drugs to make too much. So here you can see making too much muscle. This is not a good idea. So how do you find the right balance to make what you could consider for yourself the perfect body? How do you establish the balance for your muscle cells? Well, that's done by making new muscle through stem cells. So let's now go back to our stem cell picture and realize there's a muscle stem cell, and it can either be stimulated or inhibited to make new muscle fiber. I'm going to show you one example now of a signal that affects this process. In this case, it's a naturally occurring mutation which occurs both in humans and in an animal, which I'll show you in a moment. But the point here is it's a mutation on what I would call a governor, a signal which inhibits this process. Because as I've already shown you, you don't want to make too much or too little muscle. You can think of this like a governor on a race car. Well, when the inhibitor and when the signals that inhibit muscle are removed, so if you watch here, you'll see they go away, a naturally occurring mutation gives rise to this bull. You can see the farmer here is extremely proud of this bull, although he really had nothing to do with all of the muscle in that bull. That bull does not go to the gym, does not eat a low-fat diet. It doesn't do anything special. It's lost the governor, so it makes lean, low-fat, high-density muscle on its own. So the first point here then is that there are signals, natural signals, which control muscle stem cells. In this case, we've removed an inhibitor, and you see a very muscular animal. I'm going to tell you about a second example now, not with muscle, but with making nervous tissue, the tissue that allows you to listen to me, to think, to see, to remember, to study, to do your problem sets. Let's talk about making brains. It says, I'm sorry here the slides aren't showing it, but at the top it says making brains and the eye. But the key point here would be that this nerve stem cell, like a muscle stem cell, can be stimulated or inhibited. Now in this case, I'm going to show you a signal which is found in a plant which increases the inhibition. So you can see the inhibit gets bigger. If you missed that, I'm going to show you that again. Watch. The inhibition is getting bigger. All right, so during development, it's important that you make the right number of brain cells, that they make the right connections, as Professor Christakis talked about. He was talking about it between people, but they're also important between your nerve cells. I want to tell you about a story, a short story, where a plant called Veratrum californicum, found in the western United States, is rarely eaten by farm animals. It's a pretty flowering plant. Turns out that this plant contains a signal that inhibits stem cells. In particular, it inhibits neural stem cells. So in a moment, I'm going to show you a picture of the consequence of that, but the story is as follows. In certain years where there's a drought, sheep will move to regions and eat plants which they don't normally eat. In this case, they don't normally have this plant in their diet. It's sometimes called hellebore, and you'll see why in a moment. This plant, as I said, is called Veratrum californicum, contains a signal then that inhibits nerve stem cells. Well, if a pregnant sheep eats that, it prevents the nerve cells from being properly stimulated, the neural plate doesn't form, the brain doesn't form properly, and the lambs are born looking like this. So this is a stillborn lamb where the eyes and the brain have not developed properly because of the plant that the mother ate while she was pregnant. So I'm going to take that ugly picture off and say, how do we put these ideas together? That's the simple point of my big idea tonight. Putting it all together is, let's consider genetically modified foods that produce signals that will stimulate your stem cells. To put that in pictures, what I mean is let's learn more about plant molecular biology. There's been a huge revolution in animal molecular biology in the last 20 or 30 years. Let's now focus on plant molecular biology, combine genes, and then make genetically modified foods. Now what you see here on the right is a food that's been genetically modified by a very crude and tedious way over 200 years of breeding to make what's sometimes called butter and sugar sweet corn. So you can see little different kernels here. That's a very cumbersome and tedious way to modify plants, and it can be done more effectively now using modern recombinant DNA biology. So now look at this next picture and think with me about what would it be like if you ate foods that were de facto drugs. Imagine that you're now eating corn, which has signals in it that stimulate your stem cells. So I'm going to finish then with my idea and see if I can convince some of you to join me. Let's think about the following. We genetically modify foods. We modify wheat, for example, that will then stimulate muscle stem cells. We might genetically modify corn to make a corn muffin that would inhibit fat stem cells. Very few people ask for more fat, and you can reduce it by preventing stem cells from differentiating into more adipocytes. You might then also make genetically modified melon that will stimulate your brain cells. So I hope some of you will think about the impact of this on global health, on your own health and on global health, the effects on the economy, and join in on this challenge to make better bodies and healthier lives. For those who are thinking more locally, and I hope this will show up, it doesn't really say it there, so I'll read it to you. It says, perhaps those of you in Elliott will join me, and we can talk about making a real hot breakfast again at Harvard. Thank you.